Hey Lindsay. Hopefully you can see. I don't have the best setup, but it's kind of a glare. The matrix I have over here is a 3 by 3 matrix. The numbers are 1, 0, 1, 0, 2, 1, 1, 1, 1. There's different ways of finding the inverse of a 3 by 3 matrix. There's 3 different methods, and I'm not sure which one your teacher's teaching you. I tried to pick the method that I think he's teaching you, and I also think is the easiest. So let me know. There's no real easy way to do it. It's just a very long process. So the first thing you want to do is find the matrix of minors. How we do that is create a really large matrix. You have 9 spots, and there's going to be 9 spots on here. So I'm going to actually fill these in. We're basically going to find the determinant for each spot on here. So for each location in this matrix, we're going to find the determinant. And I'm assuming you guys have covered how to find determinants of 2 by 2 matrices. So I'll go over that a little bit, but hopefully you know how to do that. For this spot, we're going to look up here, and in this spot is this 1. And we're going to cross out the row and the column that 1 is in. So it's in this row, so we would cross this row out. I'll do it on just this example. I'll cross this row out, and it's in this column. I'm going to cross this column out. And I'm left with 4 numbers, 2, 1, 1, 1. That's going to go in here. I'm going to do the same thing for the rest of them. I'm going to fill this back in now. So the top row, second column, is the 0. I'm going to cross out the row it's in and the column it's in. So it's in this column and it's in this row. I'm left with these 4 numbers. I'm going to plug those in. I'm going to do the same thing for all the numbers, and it kind of takes a little while. I'm going kind of slow, but you could probably go faster after you practice. So the top right corner is this 1. This 1 is in the top row in the last column, so I'm going to get rid of these 2, and I'm left with 0, 2, 1, 1. So you do the same thing for the others. I'm going to kind of pick it up because this video isn't like super long. But this 0 is in this column, in this row. I'm left with 0, 1, 1, 1. And then this middle guy, this 2, I'm going to take out the middle column and the middle row. I'm left with 1, 1, 1, 1. So if you want to pause the video and see if you can fill in these 4, and then check your answers with me, that'd probably be a good idea. I'm going to fill them in right now. Okay, hopefully you tried these. Hopefully you can read them, but if not, this one I got 1, 0, 1, 1, 0, 1, 2, 1, 1, 1, 0, 1, 1, 0, 0, 2. Okay, this step is called the matrix. Oops, you probably can't see that. Matrix of cofactors. Doesn't really matter what it's called, but in case you ever need to know terminology. Now, what we do from here is find the determinant of each of these. Now, if you remember the determinant, which hopefully you've been taught, is you're going to take, you cross multiply and then you subtract the 2 values. So you have in the 2 by 2 matrix these positions A, B, C, D, and you have numbers in each letter position. you multiply A times D, and then you subtract B times C. That's what we're going to do. You'll get one value for each of these 2 by 2 matrix. So here we do 2 times 1, and we minus 1 times 1 from it. So I'm going to go ahead and put the answers up for those over here. So I'm going to show my work on this one. 2 times 1 minus 1 times 1. So 2 times 1 is 2, minus 1 is 1. So we get the answer of 1. I'll show my work on the next one too. So here, we're going to do 0 times 1, which is 0, and then 1 times 1, which is 1. So 0 minus 1 is negative 1. So all I did with this matrix is I did 0 times 1, A times D, minus B times C. So minus 1 times 1. And use the value, right? 0 times 1 is 0, minus 1, you get negative 1. To save room, I'm not going to actually show my work on all of these. So I'm going to erase this and just plug in the answers. So we got 2 times 1 minus 1 is 1. We got negative 1. Here, 1 times 2 is 2, minus 0 times 1, which is 0. So 2 minus 0 is 2. Okay. Sorry, this is backwards. 0 times 1 is 0, minus 2 times 1, which is 2. So you actually get negative 2. I'm sorry. Always do A times D and subtract B times C. Don't flip it, you get the wrong answer. Okay, I want you to try these 6 and pause the video and then come back and I'll put the answers up. Okay, Lindsay, so what I got here was the second row, I got negative 1, 0, 1. And the last row, I got negative 2, 1, 2. So I'll just do one more. I'll do this one, bottom left corner. So A times D is 0 times 1 minus 1 times 2. So 0 times 1 is 0, minus 2, you get negative 2. So I'm not going to show my work on all of them, but you should end up with this matrix. Hopefully you do. I'm going to try to see if I can't. The glare's kind of bad. Yeah, we're kind of just stuck with a bad glare. Oh well. Okay. Okay, so we're almost done. So I'm going to actually erase what I have and rewrite what I have up here, and we'll start from there. So let's recap. You take your matrix, you make 2 by 2 matrices for each spot in a 3 by 3 matrix. You find the determinant for each of those 2 by 2 matrices. The reality is that you'll never have to do this ever again in your life. So if you don't like it or don't get it, that's what it is. And if he doesn't show you how to do it in the calculator, I will, because that's how you do it, like on the ACT or on a standardized test. Okay, let's start with where we left off with that matrix. So I'm going to write the steps that we've done so far. We created 2 by 2 matrices for every spot in 3 by 3 matrix. And then we found the determinant for every 2 by 2 matrix. And here we are. So after we did that, we're left with this matrix. We had 1, -1, -2, -1, 0, 1, -2, 1, 2. Okay, just a few steps left. These next 2 steps are easy. It's kind of ridiculous process, but okay. So when you find the inverse matrix, essentially you're dividing, but you can't divide matrices. And so that's why all these steps are kind of ridiculous. It's because we're trying to take the inverse, and part of taking the inverse is flipping the signs. And to do that, you have to know what the signs should be in an inverse matrix. So in an inverse matrix, the signs are plus, minus, plus, minus, plus, minus, plus, minus, plus. Hopefully he's given that to you. What we do now is we literally multiply. We pretend that this is a +1, -1, +1, and we're going to multiply it by all these values in here. So a +1 times a +1 is a +1. A -1 times a -1 is a +1. A -2 times a +1 is still a -2. A -1 times a -1 is +1. A 0 times a +1 is still 0. 1 times -1, -1. -2 times +1, -2. 1 times -1, -1. 2 times a +1 is 2. So we end up with our new matrix after we multiplied by the inverse sign. Only one more step left, and that is to kind of flip what we have. So it's kind of a weird step, but the diagonal numbers here stay in their locations. This is the last step. We're going to rewrite these 3 numbers. What happens now is you flip the remaining ones. So over this line. So over this line here, we flip the numbers. So this one and this one flip. Now they happen to be the same number, so they end up being the same. But this one would now go in this spot. And this one goes in this spot. The 2 corners flip. So these 2 corners are going to flip. They happen to be the same number in this matrix, but they're not always. So this -2 goes here, and this -2 goes here. The last step, these 2 -1s are going to flip. So this -1 goes here, and this -1 goes here. And then you're done. This is your inverse matrix. This would be your answer. So let's recap the steps. First, you create a 2 by 2 matrix for every spot in the 3 by 3 matrix. Then you find the determinant for every 2 by 2 matrix. After that, we multiplied our new 3 by 3 matrix by the inverse sign. So multiply new 3 by 3 matrix by inverse signs. And then the last step is we transpose the numbers. So we flip the numbers over the middle diagonal line. So flipped numbers over the middle diagonal line. Hopefully this helps. I know it's kind of a confusing process and there's a lot of steps. But if you need to, pause the video numerous times or maybe play it once again. And let me know if it was helpful at all. Alright, thanks, Lindsay.